Hi everyone, welcome to our video tutorial on contactors and their essential role in control panels. Whether you're an engineer, a technician, or just someone curious about electrical systems, this video will help you understand what contactors are, how they work, and why they are so important in industrial and commercial applications. Let's get started. A contactor is an electrically controlled switch used for switching an electrical power circuit. It's similar to a relay, and the working principle is the same with that of a relay, but it is designed to handle higher current loads, typically used in three-phase systems for controlling motors, lighting, and other heavy-duty equipment. So, the basic unit is comprised of three poles, L1, L2, and L3. And these poles are normally open, which means in its natural state, those contacts, they will be opened. A magnetic contactor is one of the most simple pieces of electrical components in the market today. The function is simple. So it consists of a coil and contacts. So when power is applied to the coil, which is referred as the coil voltage, this creates a magnetic field that pulls the contactor's armature together. This causes the three moving contacts to then connect with the fixed contacts, thus allowing power to flow through from the line side to the load side. And it works exactly the same way as the relay works. It's the same principle. So let's look at this schematic. So on the left side, that's how the contactor looks like. You can see the L1, L2, L3 from that top side. Then you see the T1, T2, T3 on the bottom side. And then on the last connection, you see an NO. That's a normally open contact on that contactor. So let's look at the schematic on the right side. So you can see that it's exactly the same way as a relay. So you see that coil with A1 and A2 as the input for the coil, right? So one other thing that you should be aware of is that there are two types of circuits involved. We have the power circuit. You see that motor is connected to the three-phase. That's the power circuit. So you have your three-phase supply connected to one side of the contactor, and then the other side of the contactor is connected to your motor, but the motor will not run because they are open contacts there. So how do we close these open contacts? So we need to have another circuit which is called the control circuit. So this control circuit, it is responsible for turning on or off the coil. So in this case, we have our coil being controlled by a 24 volts DC supply. So once a DC supply passes through the coil, it energizes that coil, and that coil will cause the contacts on the contactor to close. And once they close, then current will then be able to flow and turn on the motor. So this is how we use contactors to switch on or off. Using contactors, we can have a lot of control systems where we can just supply a small voltage DC to the coil, and then the coil will cause the contactor to switch and our equipment can run. And we can have equipment installed even remotely, and we can still control them using this kind of simple circuits. We are using the contactor to switch on or off that motor. The motor is being powered by 380 volts, but our control circuit can just be a 24 volts DC. So we are using this to switch on or off a device. So once our coil is energized, then it closes those three contacts, and then our circuit will be completed and the motor will start to run. When we de-energize the coil, or when we disconnect the power source to the coil. Those contacts, they will then open, because the coil, it will de-energize, or it will demagnetize. The magnetic effect on the coil will stop, and those contacts, they will go to their rest position, which is normally opened position. So we are going to see how do we use contactors in the motor control. When we look at star, delta, backward, forward, we're going to be looking at how do we use these contactors to control our components within the control panel. So how do you choose a contactor for any particular function? So what you need to do is to know the rated duty. So as we are saying that this contactor, it will allow us to control equipment that takes a lot of current. So we need the contacts to be able to withstand any current that is to pass through. So that's where we talk of rated duty. So let's say for any particular function, we do our calculations to know how much current will our equipment use, and that current will then use it to select a proper contactor for our job. Right, then there are also two main types of contactors. Right, so we have what is called the AC3. This contactor is specifically used for inductive loads. So for pumps, motors, we use contactor AC3. Then we use AC1 for resistive loads. Resistive loads, these are like heating requirements. So when you are selecting your contactor, you should know, is it for resistive loads, or is it for inductive loads? The next thing you need to know is the coil energizing type. Is it 12 volts or 24 volts DC, or is it a 220 volts AC? Then the next thing is you also need to know if you require any auxiliary contacts on your contactor. So auxiliary contacts, these are additional contacts that we can put on our contactor that will give us either normally open or normally closed functionality. Then lastly, the contactor is also supposed to be sized to withstand the inrush current. Right. For example, when you start an electric motor, in its first few seconds, the electric motor will draw more current, even up to 6 times or 10 times its rated current. So it means that as you are also choosing a contactor, you want a contactor that will be able to withstand this very high current during startups. This is what we call the inrush current. Load with a rated current of maybe 3.25 amps, the contactor should be sized to 6 times that size, so it will be around 20 amps. This is necessary in order for the contactor to be able to withstand that high current during startup. So let's look at these various variations that we have. So the first one on the top left, we have a 3-pole contactor with one normally open base contact. So we have our coil and our 3 contacts, and we have a normally opened contact. Then the next one, it has got a normally closed. So depending on your function or on the system that you are building, you should be able to know if you need a contactor with a normally opened base or a normally closed, or you can have a 4-pole contactor with 4 normally opened poles, as you can see from the schematics. So these are all different variations that you can get for contactors, and selection will be based on the function or what you want to achieve with your control panel or your control systems.